Yes, you are recording. Fine.
Yes,
So it's sorting is nothing but arranging data in particular order. The particular order could be the if it is a numbers, then the order could come out to be either ascending or it come out to be descending. So, and if it is some character data, then or it comes out to be either arranging in alphabetical order. So we will consider only the numerical data right now for sorting. That is, we will consider the given are the numbers and we will sort it in the ascending order. So what is ascending order? So ascending order is nothing but the increasing order. Ascending order is as good as increasing order. Now, so if we have given the numbers, let's say some 6 numbers are given, 10, 2, 5, 9, 0, and let's say 3. Then the ascending order data, their order could be that to sort it and it comes out to be 0 first, then 2, then 3, then 5, then 9, then 10. So this is what is the output. So input is this data which is not sorted or which is not arranged in a particular order, and the output is the ordered data in typical order, that is in increasing order right now. So now there are various algorithms for sorting. Okay, so various algorithms for sorting. Some of these algorithms are that we will learn is bubble sort. The second algorithm that we will learn is a selection sort. Other algorithms are also there, which are you will learn these algorithms more detail in your theory sessions, and you will also learn their time complexity. That how complex that algorithm is in the form of order of some notations. Okay, in the form of order. Okay, or it is also called as the complexity in big O notation. It's a big O notation. So we will also see that how to calculate the time complexity of our two algorithms, that is bubble sort and the selection sort. Okay, so now let us try to understand what is bubble sort first of all, and then we will write the logic and then we will see how to code it. Okay, so now the given numbers are this. Okay, let me copy these numbers and again put it here. Okay, so these are the given numbers. Okay, so now what we have to do in bubble sort, what is done in the bubble sort, the adjacent elements are compared. The adjacent elements are compared. And if they are not in order, then swap the elements. So that is what is the logic for bubble sort. Then the swap the elements. So now here what we have, so 10 and 2 are adjacent elements. So let us have a pass. Okay, pass means iteration, the first iteration, or you can call it as pass 1. Okay, so pass 1 will go now. So right now we will compare starting from the first element. So I'll compare 10 and 2. So what I find that it is not in order because 10 is greater and it is before 2. So if we have to order in ascending order, then the 10 has to be later than the first number in this case. Okay, so what we'll do, so in this case 10 and 2 will be swapped, so it will become 2 and 10. All right, now so what will happen that, so 10 will come here, 2 will come here. Okay, so 2, 10, and the next elements are same, it is 5, 9, 0, 3. Okay, so now in this we found out that 2 and 10 swapped. Now the next turn is we started from this position. Okay, the next position is now this position. Okay, so 10 is now compared, the second element is compared with the third element. First we compared first element with the second element. Now in the second we will compare second element with the third element. We find that it is also not in order. So what will happen, that in the next turn, it will become 2 will be as it is. Now it will be swapped. So 5 will come here and 10 will come here. All right. Remaining elements will be as it is, 9, 0, 3. All right. Now the first two elements are compared. Now the third element has to be compared with the fourth element. Okay, so we'll compare third element with the fourth element. We find that also it is not in order. So again it is swapped. So what we will get? So we will get the output 2, 5, 9, 10, 0, 0 and 3. So now again the third element is compared. Now we will compare with the fourth element with the fifth element. So we found that it is also not in order. So they will be swapped. So after swapping it will become 2, 5, 9, 0, 10 and the 3 will be as it is. Now the fifth element will be compared with the sixth element and we found that the also not is in order. So they will be swapped. So we will get 2, 5, 9, 0, 3 and then 10. So we found that after the pass 1, so pass 1 will start from the first element. It will go on comparing each and every adjacent element till the last element. Okay, so what we started with comparing of the first element with the second element, and then in the second turn we compared second element with the third element, like that. So we compared everything and we found that the largest element goes at the end. So 10 got at its position, which is the largest element, which is at the end, which is at actual position. So after pass 1, so you found that after pass 1 we found that the largest element is at last position. So that means that is one element is sorted. Element is sorted. So now we have to sort. 10 is now sorted. So now we have to sort now these many elements. Okay, remaining elements. So again we will start with the first position. So this will be now pass 2. So let us start with pass 2. Okay, so pass 2 we will have now these elements. Out of these the first element is already sorted. I mean the last element is already sorted. Okay, so we will now till only this we have to compare. Okay, so now we will again start with the first element. So we'll compare 2 and 5 and we found that they are in the order. So there is no swapping required. So it will be 2, 5, 9, 0, 3 and 10. Okay, that is after this comparison. Now we will compare the 5 with the next element, that is 5 and 9. So though they are also in the order. So what is happened that the list will not be changed. It will be same 2, 5, 9, 0, 3 and 10. Now the third element will be compared with the fourth element. In this we compared first element, in this we compared second element. Now we will compare here third element with the next element, which is the fourth element. So we found that they are not in order. 0 is less and it is next after 9. So we have to swap it. So what will happen that it will be 2, 5, 0, 9, 3 and 10. So that is what is the swapping that has taken place for this. Now in the fourth turn, we will compare the fourth element with the next element. So the fourth element is 9. We will compare it with the 3. So we found that they are also not in order. So there is a swapping. So 2, 5, 0, 3, 9, 10. Now here we will compare now fifth element. So fifth element with the last element. So they are already sorted. Okay, so actually there is no need of comparison, but for simplicity we will compare till end. Okay, so after pass 2 we found that the two elements are sorted, 9 and 10. Okay, now we'll have now pass 3. Pass 3. Pass 3, that we will take this input. So this is the input for pass 3. And now again we will compare from the first element. Okay, so first element is compared with the second element. So we found that they are in order. So therefore there is no need of swapping. So output will be 2, 5, 0, 3, 9 and 10. Now in the second turn, the second element is compared with the next element 0, which we found that they are not in order. So therefore there is a need of swapping. So swapping होने के बाद it will be 2, 0, 5, 3, 9 and 10. Okay, now in the third turn, so here we compared 2, then we compared 5. Now here we will compare this with the next element, that is 3. So we found that they are also not in order. So there is a swapping. So 2, 0, 3, 5, 9, 10. Now 5 is compared with 9, not changed. 9 is compared with 10, not changed. All right. So now here we found that at pass 3, these 3 elements are sorted, 5, 9, 10 after pass 3. Now in pass 4, in pass 4, this will be the input. And again, it will start from the first element. So 2 is compared with 0. So there is a swapping. So 0 will come here, 2, then 3, 5, 9 and 10. Okay, now the 2 is compared with the next element, which is again in the order, so there is no need of swapping. Then 3 is compared with 5 element, there is no swapping. 5 is compared with 9, no swapping. 9 is compared with 10, no swapping. So once no swapping takes place, that means we have finished. That means all elements are sorted. Okay, so we found that after fourth pass, all the elements are sorted. Actually, total pass required are total passes required equal to how many numbers are there? N minus 1. So that many passes will be required to sort n elements. Okay, maximum passes. Here in pass 4 already now we got all the elements sorted. So there is no need of pass 5. All right, so we can stop it here by checking a condition whether they are all sorted or not. Okay, but if it is not all sorted, then total passes required are n minus 1. Okay, so this is the bubble sort. Okay, now so you got the logic? Bubble sort. Now let us see a logic. Okay, what will be the first step of the our sorting? First step could be the reading of numbers. Reading of numbers from user. Okay, the second step could be now. So we will require for pass 1 to n minus 1. For pass starting from 1 to n minus 1, what we have to do? Compare the element with the adjacent element. Okay, and if it is not in order, then what to do? Then swap. Otherwise no need of swap. Right, if not in order, then swap it to make it in order. Okay, so do these all for all the elements and for all the passes, and at the end of this you will find that the entire list is sorted. All right, now let us try to work it out onto our programming environment. So let us all open the programming environment, which is Google Colab.
Hello, sir.
Okay, so my bubble sort logic. Okay, then okay, so this is the logic that I have to implement. I'll comment it out. So you can select all these things and you can press Control question mark. So this will make it all comments. Okay. So now this is commenting out. So first of all, what you have to do, we have to read the element. So how to read the element? So you can read it using asking to the user how many inputs are there. So n is equal to int input enter number of elements to be sorted using bubble sort. Okay, so we'll ask to the user how many numbers you want to sort it. Okay, so n is the number of elements to be sorted. Now we got n, which is now typecasted. So you all know that you have learnt in Python workshop that we convert this into integer. Okay, by default the input is character in the Python. So we have to typecast it to integer to make it integer. Then what we'll do, we'll take that into the list or array. Okay, so we'll have ARR, that is called as array, or we can have this as a data. Okay, data is equal to we'll have actually the problem statement is the number of what is the data. It's a first year percentage of students. Okay, so first year we'll name the same thing here. Okay, so we'll ask to the user enter number of students what data, which data it is, first year percentage. Enter number of students marks to be sorted using bubble sort. All right, so enter number of students FE marks, how many students, enter how many students FE marks to be sorted using bubble sort. Okay, so that's a question that we are asking to the user. So we'll take a data. So we will take a data and we'll read it in the array using slicer. Okay, so we can do it using the slice operation. So we'll have list, it is integer x for x in input dot split. Input dot split. We'll have the message here, enter marks of students separated by space. Okay, separated by space. And then we got the data. So we will just print the data whether we are correct or not. Print the entered marks are. Okay, so we'll just print the data. All right. Now just run it. So to run it, click this icon. So let's have the 5 students and let's enter the 5 students marks. It's a CGPA or 9.78, 6.5, 8, 9.0. No, it's an integer we are typecasting, so we can't take float. So we need to take a float of it. Yeah. So I'll take integer. That's data. Okay. First of all, take integer data because we're taking floating one. So we need to typecast it to float. Okay. So we'll have 98765. Okay. So the numbers entered are 98765. So we are correct. But if you want to accept the real numbers, then we need to have it as a float. So we'll make it as float x, and then we'll try it with the. Let us try it again with the float one. So we'll have 5 data and let us enter in the percentage 99, sorry, 9.8, 9.7, 8.5, 9.0 and 9.2. Let's say these are the So we got all these data 9.8, 9.7, 8.5, 9.0, 9.2. We are correct. So now, yes, so we got the correct data into the data matrix or array. So now we have to apply the logic. So how many passes are required? So per pass 1 to n minus 1. So let's have pass. So for pass in range, pass is actually keyword in Python, so we can't take pass. So I'll take it as iteration, ITR, not iteration. Let's take P for P in range 1 to n. So it will go till n minus 1. Okay, so it will not consider n. So it will be from 1 to n minus 1. Okay, so for P in range 1 to n, incremented by 1 every one time. Okay, and then we have to compare each element. So you have seen that what we are doing, we are comparing this first element with the second element, then second element with the third element, then third element with the fourth element, then fourth with fifth, then fifth with the sixth, last one. Okay, so we are comparing these many elements. So we will go from this position to one last position, last but one. यहां तक हम जाते हैं और नेक्स्ट एलिमेंट कंपेयर करते हैं. हम यहां तक नहीं जाएंगे, यहां तक गए तो नेक्स्ट एलिमेंट कौन सा है, नहीं है, तो वी विल गेट एरर because that element is not present. So we come till only this position and we compare the next element, that is it is present 10. Okay, so how many comparisons are required? So we see that one comparison, then two comparisons, then three comparisons, then four comparisons, then five comparisons. That means total five comparisons are required if there are six elements. So we'll have comparisons. So for comparison C is in range, how many? 1 to how many comparisons are required? Actually we will take from 0 to because we will take it as a position also, to n minus 1. That many comparisons are required for comparison. For passes in range 1 to n, and for comparison in range 0 to n minus 1. So we'll have comparison if हमें इसको स्वैप करना है. मतलब क्या है, पहला डेटा ग्रेटर है दूसरे से, मतलब क्या केस हो गया, 9 इज ग्रेटर देन 8, मतलब ये C है और ये C+1 है, तो ये ग्रेटर है, तो हमें स्वैप करना है. स्वैप कैसे करते हैं पाइथन में स्वैप ऐसे करते हैं, डेटा ऑफ C and data of C+1 is equal to data of C+1 and data of, राइट. इसका मतलब क्या हो रहा है, डेटा ऑफ C को डेटा ऑफ C+1 दीजिए एंड डेटा ऑफ C+1 को डेटा ऑफ C दे दीजिए. ये हो गया स्वैप. ओके, अगर नहीं होगा तो
सर,
हाँ
सर अगर डेटा ऑफ C इक्वल टू डेटा ऑफ C+1 और डेटा और एक टेम्पररी वेरिएबल लेके किया तो,
हाँ वो वैसे भी कर सकते हैं, वो अदर प्रोग्रामिंग लैंग्वेजेस में वैसे करते हैं, जैसे सी प्रोग्रामिंग में, C++ प्रोग्रामिंग में. पर पाइथन आपको ये सारा दे रहा है ना, अलग से टेम्पररी वेरिएबल लेने की जरूरत नहीं है. क्यों डेटा वेस्ट कर रहे हो, आई मीन टू से क्यों वेरिएबल एक्स्ट्रा ले रहे हो, देयर इज नो नीड. उल्टा तुम अच्छा काम कर रहे हो एक्स्ट्रा वेरिएबल न लेके. समझ में आ रही बात?
यस.
ठीक है, ये हो गया तो मेरा डेटा स्वैप हो गया, नहीं तो फिर मुझे जाना है. हो गया, इसका सारा हो गया. नाउ आई प्रिंट द students marks or the students sorted marks are, right, and then we'll print data again, all right, after sorting. Okay, so these are the before sorting, the entered marks, the unsorted marks are, okay, that is data, and after this we sort it and then we'll print it that the sorted data are. Okay, so I'll give the same input, so I'll copy this, Control C and run it. So total 5 elements, and let us paste this. So we find that the unsorted marks 9.8, so it's there, and the student sorted marks are 8.5, 9.0, 9.2, 9.7, 9.8. So all the elements are sorted. Getting a point? Now we'll run it again with the some more inputs. So I'll copy this and we'll give some more inputs also. Okay, so let's give 10 number of elements. Okay, and 5 is already there. I'll now put 6, 5, 4, 3, 0. Okay, some 5 more elements. Okay, so unsorted data 9.8 this, and the 6.0, 5.0, 4.0, 3.0 and 0.0, because it is float, so it is converted into float. And the sorted are 0, 3, 4, 5, 6, 8.5, 9, 9.2, 9.7, 9.8. Yeah, it's sorted. Getting a point? कितना आसान है? Using bubble sort. So this is the bubble sort. इसमें passes कितने passes लग रहे हैं? So total passes are n minus 1. Okay, n minus 1. And how many total comparison in each pass? Total n minus 1 comparisons in each pass. हर एक पास के लिए n minus 1 comparisons using this. और हम इससे क्या कर रहे हैं? हम इससे चेक कर रहे हैं कि is data ordered. ओके, अगर नहीं है, ऑर्डर्ड नहीं है, तो हम क्या कर रहे हैं? यहाँ पे हम स्वैप कर रहे हैं. सो दिस इज अ स्वैपिंग ऑफ डेटा. तो ये हो गया, हमारा लॉजिक हमने इंप्लीमेंट कर दिया, उसको कमेंटिंग भी कर दिया. ठीक है, तो मतलब हमारा अभी सब कुछ ओके है. Okay, so we got it. This is all commenting and we have printed it.